Hi. One of the most important things that you're going to learn to do in this chemistry class is balancing an equation. You're going to learn how to do it in this module, and then you're going to be using it throughout the rest of this semester and next semester. Chemistry is based on, well, I won't say it's based on, but it's very important that you know the law of conservation of mass. The law of conservation of mass says that mass cannot be created or destroyed. So when we have a chemical equation, we can't be gaining mass and we can't be losing mass. It has to balance out. So that's why you need to be able to balance equations. Okay, so I'm going to share my screen with you, and I'm just going to do the whiteboard and do a simple problem with you on how to balance an equation. Okay. Okay. So when we go to balance an equation, what we're going to be doing is making sure that we have the same number of atoms in the reactants as we have in the products. So let's see how that looks. So if I have the equation H, oh, why is it not writing? Here we go. Okay, H2S plus O2 yielding H2O plus SO2. Okay, these are my reactants. And these are my products. Now, the way I always like to have my students start to balance an equation is to draw a line right here at the yield sign and just list the elements that we have on both sides. So we have the H, which represents hydrogen. We have an S for sulfur and an O for oxygen. We should have the same elements on the other side, and we do, H, S, O. And it's helpful if you list them in the same order. Okay, now what we're going to do is we're going to go back to our original equation, and we're going to look to see how many atoms of each one of these elements we have. So this little subscript here at the base of this H, the number 2, tells us that I have 2 atoms of hydrogen. If there's nothing there, like there's nothing here on the sulfur, that is understood to be a 1. So we have 1 atom of sulfur. And then for oxygen, again, we have 2. Okay, so that's the number of atoms of each of our elements we have in our reactants. Our products, we have 2 hydrogens again, okay? Sulfur, we have 1. But when we look at our oxygen, we have 1 oxygen in the water molecule and 2 more over here bonded to sulfur. We have to add those together. So we have 3 oxygens. Okay, so now when your numbers don't match, you know your equation is unbalanced. And if you take a quick look, the first thing that jumps up at you, or should, is the oxygen. Those are the ones that are definitely not balanced. Now, what tends to happen is when you balance one element, you mess up the balance on the others, and you kind of have to go back and forth a few times. Now, a couple of rules. You cannot change these subscripts here. They are set in stone because compounds have a kind of a regulated pattern. So we always will have 1 sulfur to 2 oxygens. In water, we're always going to have 2 hydrogens to 1 oxygen. That we can't change. What we can change is a number before any of these, which we call a coefficient. Okay, so the coefficient we can change. the coefficient is multiplied by each of the subscripts. So in all of these compounds we have in this equation, it is understood that our coefficient in front of each compound is 1 because we don't see a number there, but we can change that. So if we come over here to our reactants and we put a 3 as a coefficient in front of that O2, we will have 3 times 2 atoms of oxygen. So that means we'll end up with not 2, but 6. Okay, so now if we work over to the product side and we want to create 6 atoms of oxygen on this side, well, this is a little more difficult because oxygen is contained in two different compounds. So if I put a 2 here, that gives me 4 and 1, which would be 5. So an easy fix is to put a 2 here as well, which gives me 2 times 1, so that would be 2, and 2 times 2, sorry, which is 4. So the 2 plus 4 would give us 6. Okay, so now our oxygens are balanced. However, by doing that, we messed up the sulfurs and the hydrogens. So over here, we now have 2 times 2 for hydrogen. So I have 4. And on this side, I have 2 times the one that's understood to be after the sulfur. So I have 2. Okay, now come back over to your reactant side and see if you see an easy fix for this. I see it. Yay. Okay, if I put a 2 here, 2 times 2 gives me 4 hydrogens. 2 times the one that's understood to be after the sulfur is going to give me 2 sulfurs. So now what you want to do is you always want to double check your numbers. So I have 4 and 4, 2 and 2, 6 and 6. I have a balanced equation. I have made sure that the law of conservation of mass has been followed. Okay, so that's an example of balancing an equation. Sometimes the equations are given to you and they're already balanced, and that's a beautiful thing. But you should always, always check just to be sure. Make sure you're counting up the number of atoms of each element on each side of your equation, and they must be the same. Okay, if you have any questions, let me know. Enjoy the module. Take care.